Welcome to InfoFire, the fireside chat series from Information Matters. Each episode is a conversation between an expert and a host. I am Shalini, your host for this series. I am an academic with more than 4 decades of experience in teaching and researching information science. I have had the privilege of interacting with scholars across disciplines and around the world on a variety of topics, including digital libraries, iSchools, social media, ICT for development, and others. Believing in the power of digital technologies to transform science and society, I initiated many projects, including setting up the first iSchool in India called the International School of Information Management with grants from the Ford Foundation. In today's episode, our guest is Dr. Helen Sharp, Professor of Software Engineering and Associate Dean, Faculty of Science, Technology, Engineering and Mathematics, School of Computing and Communications, the Open University, UK. The topic of our conversation is Building Sociotechnical Resilience in Software Development, Experiences from the Motivating Journey project. Let me first introduce our guest, Dr. Sharp. Dr. Sharp worked as a programmer after her bachelor's degree in mathematics and master's in computer science at University College London. In 1987, she joined the Open University, and between 1987 and 2008, she held several posts at the Open University and elsewhere, including City University London, CTC Trust, and various publishing companies and architectural practices. Since 2008, she has been Professor of Software Engineering in the School of Computing and Communications. Her professional activities have ranged across disciplines of computer science, including HCI, Human-Computer Interaction, Software Engineering and Project Management, and have reached out to other related disciplines such as Education and Design Studies. In 2014, Helen became Associate Dean for Research, Scholarship and Enterprise in the Maths and Computing faculty. And in 2016, she was appointed as Associate Dean for Research and Scholarship in the newly formed STEM faculty. Leveraging her expertise in both HCI and software engineering, Helen's research focuses on the study of professional software practice in industry. She has served on several editorial boards and currently is on the advisory board for IEEE Software. Her book, co-authored with Jon Rogers and Jennifer Priest, entitled Interaction Design Beyond Human-Computer Interaction, now in its 5th edition, is one of the leading HCI textbooks and has received more than 12,000 citations. As a member of the team of the Motivating Journey to Write Secure Software Community and Culture of Coding project, a joint project between the Open University and Exeter University and a sister project of the EPSRC, Helen investigated how to initiate and sustain secure software culture, building upon frameworks of personal motivation and team culture. Since 2020, Helen has been researching socio-technical resilience of the software development environment under EPSRC's People at the Heart of Software Engineering initiative. Let us now go and chat with Helen and understand her perspective on this topic of socio-technical issues. Hi Helen, welcome.
Hello Shalini.
Welcome to InfoFire, the fireside chat series from Information Matters. Today we will be conversing about the topic of building socio-technical resilience in software development, your experiences from the Motivating Journey project. Helen, you did your undergraduation in maths and then post-graduation in computer science and joined the software industry to begin with, and then you moved to teaching and research in particularly
human-computer interaction, or more specifically, interaction design and software development. And your book on interaction design has been very well received. Congratulations. I just looked up and it has received 11,000 citations. Now, in today's conversation, we are going to be focusing more on the ethnographic studies of software development and not on the interaction design part of your journey. However, to begin with, share with our viewers your professional journey, how you got here, how did you get motivated to do maths, computer science, and human interaction design, and of course, ethnographic studies.
Okay, well, yes, so maths was sort of obvious in a sense. I was good at maths at school, and I enjoyed it. I thought it was curious and interesting. And so it was sort of almost a given that I would go on and do a degree in maths. But then in my third year, we were introduced to computer science. And at the time, there weren't computer science degrees. You couldn't go in and do a computer science degree. But you could do options in computer science. And I found that really quite intriguing. It was viewed as a kind of a subdiscipline of maths. And so if you had that logical kind of approach to things, it was sort of assumed that you'd be okay doing software development. And indeed, I really enjoyed it. I thought it was great. There weren't many courses on HCI or anything like that at the time. So I didn't know anything about that side of things. It was all very much about producing the software and looking at how the behavior could be modeled and how could you get the machine to do what you wanted to do. And then in my first job as a programmer, I met firsthand and very starkly the importance of users and the importance of people. Obviously, someone's going to use this software. It's not just about developing the software itself. Someone's going to use it to do something else. And the kinds of creative workarounds that my users, the people who were using the software I was developing, the kinds of creative workarounds they developed were quite amazing. So this made me realize, I say, the importance of user-centered design, and it shifted my perspective a little bit onto thinking about the role of humans in software development, and as I say, the users particularly. But I was definitely coming at it as a software developer, so that was my sort of perspective. And then I got into interaction design, having met two wonderful colleagues of mine, Yvonne Rogers and Jenny Priest, and they were very interested in HCI and, of course, well known in the area. And so my software development perspective on that sort of complemented some of the work that they were doing, and hence we ended up producing this series of books, which, as you say, have been very successful and very pleasing about that. That's great. It's been so successful.
That's nice. So, but why software development side? The kind of work that you have been doing, especially the community part of it. Supporting the software development community. Why is it so important to you and to the world as such?
Well, so I think software is just amazing. In fact, if you think of all the things that we do, everybody does day by day, the kinds of things that software allow people to do, what would we be like without it nowadays? What would be like without software at all? It's fundamental to what we do. You've got your apps on your phone, all sorts of things that people do with their phones and with small handheld devices. You're talking about paying bills through the bank, keeping track of your fitness, looking up the weather. There's all sorts of things that you do with your phone. But then if you look more broadly across human endeavor, if you like, for example, the instrumentation that's controlling the James Webb Telescope that's recently been launched up into space, that's driven by software. If you think of traffic light systems in your neighborhood, that's driven by software. How to model how viruses spread across the world, that's driven by software. I can go on, but yeah. There's so much which is driven by software. And of course, behind that, you've got software engineering and software engineers and developers who are actually producing this stuff. So I'm just fascinated by it. I think it's amazing stuff. And how do people imagine these things? How do they develop them? How do we make sure that that it's usable by people and it does what we want it to do? So I think that's why software development. That's what's brought me into software development. Really, I just think is fascinating stuff. But then you mentioned about the community aspect of development. And I think this is something that people they don't always take account of. When you say there's a community of developers, it's not that I think anyone will say, oh no, of course there isn't, but I think it isn't always taken into account of. And the strength of influence that the community has is really quite strong. So, I mean, software developers work in teams. So you've got the community of the team and the community of a company, maybe, excuse me. But you've also got communities across companies and across geographical locations, potentially built around programming languages. So you get communities of developers who all focus on a particular programming language, for example, Python or something like that, C++. You get people who are focused on particular development methodologies. So agile software development is one of the things that I've looked at a lot. So you get communities built around that. And these are really quite strong. We did some work early on around object-oriented development. We were trying to understand what happened with the object-oriented development wave, if you like. Object orientation was originally sort of I suppose you can say invented, if you like, a long time ago, but it took quite a while for that to actually reach the commercial software developers and to really take off. And so we wanted to understand what caused that. Why did that happen? And there was one story which is an official story, but when we looked at contemporaneous literature to try and understand what actually happened, it seemed that there was very little written about object-oriented development. There's very little evidence in anything published or any kind of conference proceedings, any kind of practitioner literature. We looked at a whole range of things to try and understand. But then suddenly the UPSLA series of conferences appeared, and there were lots and lots of people who turned up at these conferences. So there was obviously an appetite somewhere that had been built up, which then was sort of released in a sense when the commercial development for C++ was available. So there were people who could pick this up and actually start really using it. And it's quite surprising how it suddenly burst onto the scene. And from looking at the literature, we concluded that we think it was basically a community was being built up behind the scenes, so to speak, in informal conversations and informal links where people weren't writing any publications down. So community is actually very strong. And I think in all the work that we've done, we've found an influence of local meetups and these cross geographic communities has been very influential in what they're doing.
In fact, someone says that softwares are sort of artificial things that are created by human beings. So there is this how you bring in, we as human beings are creating this software, which is an artificial thing. And then there is a community behind it, which has its own dynamics. So that's where I guess all these complexities come. So there is a sociological aspect of it because there is a community, there are people, human side to it. And then since the community is there, probably you may have to look at the sociological aspects of it. And that's where probably we come to the ethnographic studies later. Before that, I have this question about, when we talk about software development, one aspect of software which common people generally are, you mentioned software drives everything without we realizing it, right? As a common person, everybody uses a phone, everybody uses a computer or watches things, etc. And there is behind that software that is doing the things. But people get sort of, startled or worried only when they see that there is a security problem, right? And the software security issues actually hit the headlines every other day almost. So people, and including the software committee, is always saying that, how did this security issues never go away? Haven't we come a long way? You said, no, there is this built up, we have computer science or software development has a long history. So how is that even today, every other day, we see that, breaches due to vulnerabilities, etc. So could you give us some real life examples of how important security aspect of software development is from your experience?
Yes, sure. I mean, I should start by saying I'm not a security expert. So there are people out there who will know far more about security than I do. I come at this as from the perspective as a kind of an ordinary software developer. So I just wanted to make that clear. So vulnerabilities, if I can just start from that, vulnerabilities in software are sort of points in the code where what we would call a malicious person, so someone who has ill intent, shall we say, in what they're doing, where they can sort of take over control of the software. So they can get inside the software and either, I mean, for example, steal or change data or change the behavior of whatever it is that the software is controlling. So if they get into networks or they get into people's computers, that's a kind of a vulnerability. There are points where that kind of thing can happen. And then an actual breach happens when somebody exploits that vulnerability. And so someone actually does something malicious to a piece of software. I think a lot of people think of it nowadays in terms of stealing data or stealing identity. And indeed, that is one of the sort of common threats that people face. For example, in 2017, there was a security breach at Equifax, which you may have seen on the news. And it was, I understand, it was 145 million people lost their data. So that can be names, addresses, but it can also be passwords and potentially credit card information or something. So the malicious person steals this data and then, as I say, pretends to be that person. Individuals lose money because someone else is spending their money out of their accounts. So I mean that's one example. And there was a similar breach happened to British Airways the following year in 2018, again, where data was stolen of passengers and anybody logging into the British Airways site. And then, as I said, they can lose money and people can take their identity. But that's not the only thing. Another example is where you've got malware or ransomware. So ransomware is where something gets into your computer and then sort of potentially locks you out of what you're trying to do, or something that says you must give money to this particular account, and so hence ransomware. And one example of this was the NHS, the National Health Service in England. Again, in 2017, there was a security breach called WannaCry, and this locked out a lot of NHS workers from their computers with this demand for money. And in this case, it wasn't about stealing data. It was about trying to get money out of people, but it was it disrupted. You can imagine it disrupted operations. It disrupted hospital and GP working, and it cost a huge amount of time for the IT to sort it out. So these are the kinds of things that when there's a breach, it can be something malicious like that. So obviously, we want to try and avoid that. As you say, the frustration often is that these things are caused by well-known and commonly understood problems with the code or weaknesses in code. I mean, software development nowadays is such a complicated thing. You're pulling code in from a range of different places, from libraries, from other people's software. Obviously, software, any one piece of software is linked to lots of other bits of software. So there are lots of complexities in here about where, how do all these things work together? But these code vulnerabilities, a lot of them are well known. And there are public lists of these vulnerabilities. There's something called the OWASP list, which lists the most common vulnerabilities. So there's a lot of frustration around that. And I think that's where there's often a question arises as to why don't developers code software to be more secure? And there is this sort of rhetoric which suggests that it's the developers who aren't paying attention or who don't know enough and need to be educated or something like that. But there's quite a lot of rhetoric around the developers. It's the developers' fault. And that actually led us to the project we're going to talk about later, which is Motivating Jenny. That's where we ended up with that project, because we were asked that question. Why does this happen, and how can we motivate developers to produce secure code?
So, could you explain to our viewers what exactly do you mean by, is it meant that socio-technical resilience, and how important this aspect, the socio-technical resilience, is to just technical aspect?
Yeah, that's a good question. Socio-technical resilience is a very slippery concept. And in fact, I have a colleague who's currently reviewing the literature to try and understand how has it been defined by a range of different people over several years. But I won't get into that for this conversation. That's a bit too much. So for the purposes of this conversation, I would say that socio-technical resilience, it's the ability of a socio-technical system to remain stable enough to operate safely in the face of change. Okay. Things are changing all the time. So when I say in the face of change, it's not like one particular thing happens and you have to remain, the system has to remain stable. There are things changing all the time. And particularly if you think of software development, people change, policies change, the requirements from the user changes, the knowledge that hackers have changes. So people, these malicious people again, they learn things all the time. So things are changing all the time. So the environment around software is constantly changing. So the notion of remaining stable enough to operate safely in that context is, as I say, not just about large events, it's about day-to-day things. Every time someone runs a test, for example, if you're doing software, you run a test, we are often told by developers that something just isn't right. It just doesn't feel right. And they will adjust what they're doing because something doesn't feel right, or they'll investigate something a bit more to try and understand what it is that's not quite right for them. And then they'll make changes. They respond to whatever it is that they find. And those kinds of things are day-to-day events which help to support the socio-technical resilience of the whole system that supports software development. And that's the kind of thing we're trying to look at. You also sort of made the point about it's not just about technical aspects. I mean, obviously technical is important because software is technical. You need to understand the languages, the libraries, how to make things work. There's a huge amount of the technical side. But if we think again about the fact that it's people developing the software, and when I was a software developer myself, as I was saying at the beginning, when I first became a programmer, I think it hadn't occurred, so it's a daft thing to say now, it hadn't occurred to me that, of course, people develop software. So all the quirks and the specialities and wonderful things about humans, that comes through in software development too. So you've got the human developing the software itself. And then you've got this community aspect. So you've got people supporting each other through social connection across the communities, which may be global, across communities within a particular team. So you've got quite a lot of, again, this social influence on what is happening and how software is developed comes to the fore. So you need to put the technical together with the social. Technical solutions can be chosen by the community. If you look at something like Stack Overflow, I don't know if you're aware of Stack Overflow, where a lot of developers go to this, is an online forum, and they go there to find help and support. And one of the things that people often do is find bits of code on Stack Overflow, which they may well pick up and then use in their own work, having tested it and carefully made sure that it does what they want it to do. But even at the level of code and finding technical solutions, communities can be quite influential, because if enough people pick up the same bit of code to use, then it will become more popular within the community and will be used more widely. So I think there's the social side, the community side, these things underpin and really change the way the technical side of things are used, the technical techniques are used. So it's, as I say, it's a really important combination of having those two things together, the social and the technical.
So would that, the For example, you mentioned that the social aspect, the community aspect, and all of the supporting each other is an important factor. Would that be the reason behind why open source software community? Because there is a large community out there which probably support each other, and they can have their own, of course, individual groups, etc. Could that be the reason for the popularity and I would say the progress advancement that I've made in the open source software as compared to proprietary software?
I think, yes, I think the open source community is a very interesting community. And I think that's right. I think there is this very strong community feel around certain products and certain groups who work on the software. I mean, I've been told, as you mentioned, I do ethnographic studies with software developers, which basically means that I spend a lot of time with software developers, finding out what they do and how they work. And it's incredible the number of people who, they go and do their day job, and then they go home, and then they carry on coding, either because they're working for something for themselves, or very often they're working in some kind of open source community. So they're sort of volunteering their time. This is not, I mean, sometimes you get open source. I mean, nowadays there are more open source projects which also have some proprietary input. They have sort of company input. But yeah, it is incredible how people put their time into supporting the community. So yes, I think open source communities are very, very strong, and it does make a big difference to them, I think.
So coming back to the socio-technical aspects, and particularly your project, Motivating Jenny project, which is all about trying to understand the motivation behind this, the motivation. See, we are all, I mean, probably everybody is familiar with Maslow's hierarchy of needs. So you have framed your Motivating Jenny study with this theory, motivation theory. So could you explain to our viewers what exactly motivation theory, and what are the let me say outcomes or findings of your Motivating Jenny project?
Okay, yes. I mean, motivation is a huge subject. Maslow's theory is well known, and there are many others. So I think rather than spend the next sort of 4 or 5 hours trying to explain a whole bunch of different theories, I mean, what we did, and in the work that we've done, and I've been working on motivation in software engineering for quite a long time, and we started out by doing a literature review to try and understand what do we know about motivation in the context of software development, software engineering, and so we're specifically looking at software developers' motivation. And one of the things we found, in fact, was that a lot of the studies that had been done up until this was done in like the mid-90s, 1990s, a lot of the work being done up to that time had confused the notion of satisfaction and motivation, and they are actually distinct. They're distinct concepts. And I then did some work with some Brazilian colleagues where we did some empirical work with local companies in Brazil to try and understand a bit more about this, what is satisfaction and what is motivation and what motivates people, software developers, and how can you tell if somebody is motivated. And we then came up with a model of satisfaction and motivation, which pulled those two things apart. It's quite a complicated thing, but there are papers that you can look at if you want to see sort of what was going on. But so we did that sort of empirical work. And then when this security question came along about why is it that we keep getting these vulnerabilities in software, and why don't developers just develop code that is secure, the question was framed in terms of, can we motivate, how do we motivate developers to write secure software? So we started from the position of thinking, oh, right, fine, what we need to do is motivate people to do this. And there were two theories that we used as the basis for that, as well as using our own work and sort of building on the work that we'd done previously. There were two other theories that came into play, which are quite influential in this area. One of them is Teresa Amabile's progress principle. And that basically says that knowledge workers, including software developers, are motivated by making progress, which is a fairly simple, on the one hand, is a very simple kind of thing, but is actually quite powerful. And software practitioners I know recognize this. They agree. They think this is right, correct for them. So that's one of the things, of making progress. And she's also got this notion of an inner work life, which looks to the individual and trying to understand the individual's experiences and how they view work, their work, sort of themselves. So we drew on that one, and the other one was Edgar Schein's Career Anchors, which looks at how a career progresses. That's an older piece of work that's been around for quite a long time, but these two things, together with the work we've done previously, allowed us to identify a set of internal and external factors that we believed influences behavior and within software development. And we used that kind of thing as an analytic when we went into our ethnographic work. So that was the kind of the framing of it. We were trying to understand how to motivate software developers to write secure code. And we were using these sort of background theories in the previous work as a sort of a way into trying to frame, as you said, frame the question and frame the investigation. So when we started, so that's where we started the project. That's where we were. But when we started, then actually going into companies, because we took an ethnographic approach. So we worked with two companies quite closely. We did some online work. I mentioned Stack Overflow before. We worked online in Stack Overflow. And we also did quite a lot of work with conferences and in these meetups. Again, I've mentioned these communities that exist around the world and locally. So we went to meetups. So we engaged a lot with practitioners to try and understand this question, get a handle on this kind of question. And it came fairly obviously, fairly quickly, that actually motivating developers to write secure code wasn't the right question, because the situation was basically a lot more complicated than that, as you might expect. But developers that we worked with, they understood about security. They knew about the OWASP lists. Several of them sort of would read articles and things. So I mean, there wasn't this sort of sense of we don't know anything about it and we'll only do secure code if we're told to do it, which is, again, some of the rhetoric that was around. It's that developers just aren't doing what they're supposed to be doing. And this project was only 2 years long, by the way, so it was quite a lot of work to do in 2 years. But yeah, so something important also to just point out is that we weren't working with security experts. We were working with companies who were, in a sense, were ordinary software development environments. So one of them, one company provided workforce management software, so was developing workforce management software. And the second company was, they specialized in solving tricky technical problems. So they were much more oriented to sort of detailed back-end kind of tricky things to solve. But as I said, security wasn't there. It wasn't security critical software that they were doing. So where have I got to? What did we do? I mean, the output, so it was a 2-year project. We worked closely with these companies. We saw various people. We were trying to, as I say, understand this kind of motivation question, but then realize that it wasn't that simple. So we ended up at the end of the 2 years with an empirically grounded view of what does security look like from the developer's point of view. So the thing about ethnographic studies is that it's always trying to understand the individual's point of view. And in this case, it's the software developer's point of view. So we had this empirically grounded view of security. And at the core of this, there was a set of what we called responses that an individual may have when they come up against some kind of situation which involves security. And remember, this is the context of ordinary software tasks. So this wasn't being emphasized by somebody else. This could be that they needed to just sort out access to a database or something, and there were security protocols they had to go through to do that. One of the things that we output from this was a set of practitioner packs, which allows and helps and supports teams and individuals to recognize and work on their responses, the responses that they find in their team, and to improve their security culture. But for a minute, let me just talk a little about what these responses are, because you're probably thinking, what am I talking about? This all sounds very peculiar. But so there was a set that we found of 5. The list is not exhaustive, but I will just describe 3 of these just to give an illustration. So one of these things is what we call worry. And this is a situation where an engineer is aware that a design choice that's been made within the software has poor security implications, but they're not empowered, for whatever reason, to actually change that decision. That may sound quite curious, but we came across a number of stories where that was exactly what happened, where somebody else in the organization, someone higher up in the hierarchy or one of the clients for the software, insisted that what should be done is to stick to certain standards rather than to understand the specific circumstance that the engineer is looking at, and accept the fact that what the engineer is saying is that following the standard in this case is not the best solution. We should be doing something else. So the response from that engineer is then to worry about it. They know that it's the design choice is not the best for that situation, but they can't do anything about it.
So the programmer or the person doing writing the code is not empowered to adapt to the emerging situation, right? That's right. Okay. So there is this hierarchy, there is this protocol or clients, whatever. Okay, got it. That's one.
Yes.
So
that's one of them.
One of them. Go ahead.
Okay. So a second one is something that we've called guide. So a guide as in taking people along somewhere, guiding someone. Yeah. And this is where an engineer provides support for localized problems. So this is, if you imagine a team situation where someone is having trouble with working through a protocol. I mentioned the security protocol. So not quite sure how to handle this protocol in this particular circumstance. And this response may be from another engineer who says, well, I know about this particular piece of code that you're working with, and I know enough of this protocol thing to help you. So they sit and work together with one of the engineers guiding the other one through security hoops and understanding. So they work it out together in a sense, but you've got someone who says, I understand some of that, and I'll help you to do this. And so it's, they give helpful pointers to others. They know enough about the software. They know enough about different types of security. But again, they're not a security expert. And one of the situations we saw this happening, the engineer who was doing the guiding said, I'm not a security expert. I just know enough, and I've done this myself in something similar, so I can guide. So that's the second kind of example. And then the third example I'll give you is something we've called direct. And that's where an engineer actively engages in a security issue or security problem. And they say, right, I'm interested in this. This is part of what I have to do. And then they go away and they research it and they look up on forums and really try to work through what is this security issue? How should I deal with it? And then are able, hopefully, if they're empowered, they're able to then use their research actively in the kind of software that they're developing. So they're 3 examples. I hope that makes some kind of sense. But each of these things has an impact on the security culture that you have in a team. And at the end of the day, what people want to do is improve the security culture. So how is security handled? Who deals with it? How do we make sure that everything is secure? This is something that that all teams are looking for. So each of these roles actually makes a difference to the security culture. And if the team can learn to identify these different responses and to respond to the responses, but identify them and then work out how to handle it. So if, for example, if you end up with a number of people telling you that they're worried about the security in the software, as a manager, you can either decide to ignore that, hopefully you wouldn't, or you can sort of think, okay, well, so why is it that a number of my engineers are worried about this solution we're working on? What should we be doing about it? If you find that there are a number of people, or you find that there are people guiding others, well, I wonder whether we should harness some of that local knowledge and do something with it so more people can benefit from that knowledge. Maybe we should allow that person to be a bit more flexible in terms of where they work and who they work with. So there's a range of things that you can do when you realize what kinds of things are happening within the team. And the practitioner packs that I mentioned at the beginning that came out of the project, these are intended to help teams and individuals get a sense of what is happening within their team in terms of these responses to security. So how are they working? They learn, it helps them to learn from each other about things they know around security as well. So it's trying to support that. So in the project, we try to produce this whole holistic view. It's an academic view, which is an empirically grounded view of security, what is happening. And then there's the practitioner packs. The bit that I haven't come back to is motivation and the framing that I mentioned at the beginning. So what is it that causes these different responses? Again, is a number of different factors. There's workplace factors. I've mentioned the notion that maybe higher up in the organization, someone doesn't want an engineer to make the decision, they want standards to make a decision or something. So you've got different workplace kinds of factors, but you've also got the individual's experience. And again, this thing that Teresa Amabile calls the inner work life, and Edgar Schein's career anchors. These things are individual factors. All this stuff comes together and influences which response an individual will have to a particular security situation. Does that make sense? I feel like I've talked an awful lot about a lot of intertwining things.
Anyway, we can go on about these things because we have come to the last part. I mean, in a sense, crossed our limit. So just towards the end, thank you so much. But I would like you to have, I mean, I'm sure you are an inspiration for many young, particularly women. We all have to do this, inspiring thing for women. So I would like to ask only one question, like, how did you combine these two? I mean, they're related, but streams of human interaction design or HCI, and then software development and this ethnographic studies, etc. How did you combine the two? And you are taking away of this from this, and could you explain to us in, I know, very briefly, of course.
Yes, sure. No, that's fine. I mean, yes, because obviously software development, as we've said, is a very technical kind of thing.
That is the center,
and that's where a lot of people focus, indeed. So I think what my understanding, my realization of user-centered design and the importance of HCI, I think what that gave me was a different perspective on the software development endeavor, both from the human and social aspects of the team and the developers themselves, but also the users, the final users of the software. And of course, software developers are themselves users, not because they use their smartphones, but because they are using libraries and they are using development environments and all those kinds of things. And at the time when I started, no one was looking at how good are these systems for the developers themselves. They didn't view them as users. So the HCI and interaction design kind of approaches gave me the techniques and the tools and the perspective that allowed me to see software development from like the other side, if you like, to say, okay, so not only have we got the users, who are important, obviously, but we also have the people who are developing the software. They are users, they are people, they are teams. There is this social situation that people work in. And no one was really paying attention to the developer's point of view. And ethnographic studies give you one of the tenets of that is looking at it from the developer's point of view, from the internal point of view. So yes, so I think there's, of course, my career has actually been divided in a number of different things. I have done straight interaction design research projects as well, which we're not talking about today particularly, but so I have done those as well. But I think it's the perspective and the tools and techniques, the practical ways of how do I investigate that and how do I look at it. And it's been fun. I mean, it's been doing an interdisciplinary approach like this is just so interesting, frustrating. It can be very difficult at times, but fun and really rewarding. So yeah, it's been great.
Thank you so much. On that note, I mean, I would agree with you totally that, everything, you can always bring the knowledge of one to the other, because end of the day, it's the same in one sense. At the surface level, it may look different, but if you go deeper, foundationally, it's the same. That's what even the systems theory approach and all that is that, right? So everything went up that, right? So on that positive note, once again, thank you so much, Helen, for sparing your time and sharing your personal perspective as well as what motivated you to get this.
Indeed, yes.
Okay. Thank you so much. Okay.
Okay, thank you.